Hello. Hi, Mirak. How are you? Hello. Hi. Good evening, Mirak. How are you? Unmute yourself, Mirak. Hi.
Hey,
Unmute. Yes, that's better.
yeah,
Now you
perfect.
can speak.
Yeah, thanks.
Yeah. Hi. Good evening. How are you?
Good evening. I'm good, thanks. How do you do?
I'm fine. Thank you. Thanks a lot. Thanks a lot for joining us at this hour. And I really appreciate you giving us some of your valuable time also. So I'm just waiting for some of us to join us up.
Sure,
Okay. And with
sure.
your approval, I'm recording the session also.
Okay,
Okay, and it would
okay,
be shared with you also side by side. Okay, so I have
all right.
some of them already. So before others can join us, I will go ahead and introduce you to the gathering so that we can utilize our time very quickly with that manner. Good evening, participants. I welcome you all to another part of our masterclass session, taken none other than Myrick Bayless. Okay, I hope I'm pronouncing your name correctly in that manner. Okay, now he is from Prague, Czechoslovakia, Republic of Czech, and he has been involved into a lot of projects, I would say, and before coming in to the implementation of the search engines and analytics for the credit bureaus also. Now, since this is a workshop, I should say, on qualitative analysis, here is the individual who comes from the industry front as a software expert, I would say. And he is also trying to showcase to us as to how to go ahead, look at the search engines and try to understand the popularity of the analytics of the credit bureaus also side by side. Now he has delivered a lot of sessions on a similar kind of subjects, both technical aspects of it as well as the business side of the, I should say, the business part of that particular industry. And he really is going to showcase to us in this particular session with all of us, and I welcome you in that manner, Manas, a tool called as Elasticsearch, and I could not understand anything about it, to be very honest. And I really want to see, how to we can go ahead, use it as a search engine and understand the analytical part of that side of that particular tool. So without wasting any time, I welcome you, Marek, and I really appreciate you joining us up so late in the evening. However, time does not matter when it comes to learning or understanding certain things. So now I go ahead and leave the entire session to you. With this, that as you say, maybe an hour of presentation from your side, and then we can pick up some of the questions which are being raised by the participant. And afterwards, again, you can start off with the other part of it. So, all right. Thank you for joining us up this evening. So all
Thank
yours
you.
now, Margaret.
Thank you very much for the very nice introduction. Thank you very much for sacrificing some of your Friday night, because I believe it's, what time is it in your region? It's
Right.
9 or
It
something.
is 9:35 in the
Yeah.
evening.
So so thank you very much. You decided to spend time with me and listen to my presentation. So let me try to share my screen first of all. Entire screen. Perfect. Right now you should be able to see my slides. Please let me
No.
know whether.
Yes, it is uploading. Thank you.
Okay, okay, perfect. So first of all, just a brief introduction about me and my background, because I believe that's very, very much important. So I am Mirek or Miroslav Valeš. I am software architect and product manager of CBS, which is a credit bureau solution. It's a flagship we are developing in Credit Info. Credit Info is originally an Icelandic company which expanded to many places worldwide. As you can see on this map, we've been delivering bureau solutions or just giving a consultancy on credit risk and credit analysis to multiple countries worldwide. So it's very interesting field of work. And our main product, CBS, was delivered to countries like, for example, Indonesia, Morocco, Georgia, or also some Asian countries. Or, for example, the new instance we have is in Oman, where we were as a vendor. So it's a very interesting business for me. I'm grateful for it. I'm with Credit Info, and based on this industry and based on this involvement, I was able to spend a lot of time with the client when delivering these credit bureau systems, and also frequently was involved in search engines and search solutions. So my session will not be completely about qualitative analysis. It will be more about search solutions, interesting cases, but I still believe it can be very fruitful for you because from one perspective, definitely search engines are captivating to learn more about, but also for the analytics and for processing of data, which you after all can utilize, it can be beneficial. So I will tell you something about search engines, at least in my simplified approach. I will show you something like key concepts of Leucine and Elasticsearch, how they are connected and what are the main ideas behind of them. And also I will share with you my main points on designing and implementing some search solutions. So let's start now with some basic introduction into the key concepts. I tried not to fall into some existing categories and also to make it lean, because I believe this will be the best way how to serve it and how to make it simple to understand. So I'm establishing a term search solution, which is simply some combination of computer system modules which are there for the purpose to search and find some data or information in data corpus. The data corpus can vary. I saw many type of data corpuses, so there are some qualification criteria we can use. It can be either structured or unstructured data. We can think of it like primary or secondary data. In case of secondary data, I mean by that this corpus is generated using a data created by another system. So let's say you have a business system with a primary source of data, and you are pumping this data into another system, another solution which is there solely for the search purposes, and from which you are taking the search information back to your primary system. Also, in some cases, the data corpus, if we are interested into the type of data as such, can store business data, and in some cases, it's just about operation data like logs, like monitoring, like events data, and so on. When we dig deeper into the search engines, we will find out it is very important to distinguish between data which are indexed and non-indexed. As we learn later, the indexation is all about trading some performance and speed now for getting faster search later. And also in most of search engines, it is possible to decide whether some scope and some content should be stored and be available as a part of the search result, or it should be not stored and we are just interested in some, let's say, pointers. This is very nice scheme, which is just showing there are providers of data. Here I call them data pumps, which are sending data pieces into indexer. We can have one indexer or multiple indexer. This is typically based on the volumes and performance needs. And finally, we have some database which can contain some index with data prepared for search. And on the opposite side, there is some daemon or some service which is searching through this index and providing the most relevant results based on our search criteria. And finally, of course, we need some UI or simply just some interface, not necessary user interface, but some machine-to-machine interface. So we are able to pass search criteria to these solutions and get the search results back. So this is just a really like basic specification and definition of the field in which we'll be moving, or around which we are going to revolve. And now I'd like to mention, at least from my perspective, more about the roots of Leucine and Elasticsearch, because each time I'm looking at some very good and nice software solution, after some time I'm going to find either very talented software engineers, or in many cases I'm also stucking at Apache Foundation, which is well-known entity divided into many committees. If you have time, ambition, and if you are capable to join one of these committees and take care of their open source projects, it's great, I think, also to gain some knowledge. And they started in year 95 or 1999, depends how do you see it from the organization perspective. They were developing HTTP server, which was again nice open source solution. And from the purpose of this meeting, there is also Apache Leucine project, which was developed by Doug Cutting. He wrote it originally in year, I think, 99, and it was a great contribution to open source search engines. Not only at that time, but still, if you are looking for nice open source search engine library you can use for your project, this is the best point to start with. And the reason why this guy, the software engineer, was able to create such a successful search engine was he was not doing this for the first time. He already written multiple search engines because he was employed in Apple and also in Xerox. Again, Xerox was playing a role of incubator of many great design and software solutions. And he came with this search engine, which was his, I believe, maybe fifth search engine he developed, and he named it after his wife. So the Leucine is actually a middle name of his wife. And later on, and you can see it here on the list in the middle, he also started another project, which is like an offspin of Leucine, Apache Nudge. And this Apache Nudge is a crawler for web pages. So it's like a robot which is able to skim over web pages automatically and extract some data and send them for indexation. So the key takeaways from here: there is an Apache Foundation, great source of open source projects. They are providing libraries. They are providing many new communities with interesting ideas, which are all available with source codes, which is perfect for software engineers. And when it comes to the search exclusively, there are some projects derived from Leucine. One of them is Apache Solr, which is another search engine which can be used sometimes concurrently to Elasticsearch. And another one actually is a Compass, which was beginning of Elasticsearch project as such. What is the relation between Elasticsearch and Apache Leucine is something we will discuss a little bit later. But first of all, I'd like to show you some fundamentals of Apache Leucine, how it works, what are the clever solutions inside, and later we will see how this clicks together with Elasticsearch and how we can use it. So first of all, if we take at Leucine, it is a combination of search and document database. This is depicted here on the right side by this blue diagram. In case you are providing some search input, some search criteria, let's say it can be name and identifier a subject, it can be registration number of a vehicle, and you are sending it into the Leucine. Leucine is taking a look into its term index, where all combinations of words or words are already indexed, and in case some result, some document is found, this data set, this hit set can be augmented or let's say enriched by a document which is stored in a separate store. So if you really don't care much about the search functionalities of Apache Leucine, it would be possible to use it as a key value store. You would be able for each unique key to store there a document no matter what it contains and receive it using this key, which is after all some very simple search if we put it very simply. But Leucine is very good because it allows us to design much more complex indexation process. We are able, and we will see it later, we are able to design how the incoming stream can be split into the fields and their values, and also which transformations should be done. Also, if we take a look on the diagram in the middle, this shows how the indexation is working using an inverted index principle. So on the left side, we can see two documents. First one, let's say it's a book on an article, and the first one contains just a simple text, "Hello world," and the second one contains "Welcome to my world." Leucine uses inverted index, which is represented by this small table with the five rows. And as you can see, it is something very similar you can find in many books at the end of the book. So for each term or for each word, for simplicity, there is information at which document I'm able to find such term. So for the majority of the terms, it is just from single document, but for the word, it is actually pointing to document with ID 1 and 2. And the orange boxes are providing an example in case I'm sending a query to the Apache Leucine, to the instance of Apache Leucine with index data, which is asking for content in a body which should contain two terms, my and world. I will receive feedback, which is information two, because based on Boolean logic, there is only one document which is satisfying existence of both terms, which is my and world. So we will get number two. The whole question why to use inverted index is actually about this one. It is the question whether, and for some small data set, it can make sense, but not really for search engines, whether we really want to compare entity or token one by one in real time, or whether we rather want to store data in a way it will be very fast for searching. So this is some extract from a book, from an end from a book, and you can see there is a list of terms or expression, let's call it, and there is also reference to a specific page. What is there additionally in this screenshot is this index contains, in some cases, some additional metadata. For example, what happened to this subject, whether this guy was Protestant or whether this guy was a bishop, and so on. This is important also in Leucine, because in Leucine, the inverted index is not constructed only using the term itself and a reference to a document. It also contains some additional data which can be again used for better searching. If I focus only on ingestion of the data, it looks like this. Please read it from the left to right. So we start with some stream, with some document or set of documents. And in Apache Leucine, you can design a set of something they call analyzers. Analyzers, simply put, are procedures or functions which we can put into a sequence, into a processing pipeline, and they are changing and modifying the input stream. So the most necessary one is a tokenizer, which is there to define what a single term is. So we are able to tokenize a sentence using by splitting a sentence by let's say space characters or by commas. Also, we can specify a filter, so we can get rid of noisy terms and noisy tokens. So typically, an articles are completely omitted in case of full text search. Or I can also implement some more, let's say, from perspective of performance consumption demanding processors, which are lemmatizing or phonetically hashing the content. Phonetic hashing, I will show you something more later. For now, this is good just to know, like really we are able to cover a lot of use cases and a lot of needs when it comes of way how to prepare the data to be transformed into a term and then saved into the term index or inverted index. When searching, the search is based on some query. In the query, we are passing search parameters. So each query can be requesting content which is searched in a specific field. Because the document which is stored in and indexed in Leucine can be structured as a set of multiple fields. So let's say if it is representing a subject, I have a document subject which contains date of birth, as well as first name and surname, as well as contact, for example. And for each of those fields, if they are indexed, of course, I'm able to use them in a query and specify which values I want to search for. So here we got very simple example how I'm also able to request a score boost in a Leucine query. So I'm searching. There is no differentiation between the field in which I'm searching, but I'm able to search for two terms, and the second one is boosted by 4, which means if I have some set of results, I will get the better position for those which contains Boston when compared to those which contains city term. Simply put, in Elasticsearch as well as in Leucine, scoring is based on frequency on the terms in a collection. And of course, the terms with higher frequency and higher density are put on the first places. Now, finally, because I mentioned Elasticsearch many times, so maybe it's a good time to start also explaining what is the relationship between Leucine and Elasticsearch. So far we understood that Leucine is the cornerstone. It's the primary origin, the primary search engine, which was used for many additional spin-off projects, and Elasticsearch is one of them, or at least can be seen as one of them. So Leucine as such is a library which can be used in your projects, and Elasticsearch is more like a solution. which is solving many use cases and many problems which are needed in enterprise-ready solutions. So in Elasticsearch, what they did, uh, of course, in time, it wasn't built in a day. They surrounded it and augmented Leucine by additional pieces and additional services, which are fulfilling an ability to use Elasticsearch and after all Leucine for multiple tenant scenarios, as well as for distributed search solution, which is really important because by having a system distributed, you are also able to achieve scalability of the solution. You are also able to have highly available solution. So even though if there is a, let's say, incident and one of your servers is under fire, there can be again another 2 servers which are stepping in and taking the volumes and the operations without any deterioration of the quality of service. So this is something that was not completely possible with a single library, Leucine is. But with Elasticsearch, it is possible, as well as there are many additional features related, for example, to making backups of the indexes, making indexing more convenient. Because in Leucine, if you want to specify something, design, let's say, digestion pipeline, you after all need to be proficient in scripting a little bit. In Elasticsearch, you don't need to be hard code programmer because you are able to configure most of the things with a tutorial. So I think Elasticsearch is also an ability to go more mainstream, which Leucine definitely was not. And when we take a look from the perspective for use cases, of course, Elasticsearch is typically used as a search engine for full text search, but also we can use it as a store, and I mean searchable store for logs and monitoring analysis. So we use it a lot, for example, to save data, how server is doing, what is the utilization of resources, whether a server is online or not. All this data can be stored into the Elasticsearch, and later you as an analyst can take a look and identify some problems. So for example, if some of your servers is down, you can take a look into Elasticsearch and find what was the latest reported status, or for example, when utilization of memory started peaking and so on. But the same principles can be used also for non-technical data corpuses. So if you want to, you can digest whole books. You can send there, for example, recordings of communications. We did some interesting projects because in the Czech Republic there is a parliament, and also, yeah, as a part of these institutions, they are recording everything what is said as a part of daily speeches, and it is a great data corpus which you can nicely send into the Elasticsearch, and then you can search for specific patterns. So it is very variable and elastic solution. In some extreme cases, you can use Elasticsearch also similarly to Leucine as a key value document store, but frankly, usually there are better solutions if you are just looking for no SQL database. In some cases, also you can use the features of the ELK stack. What is ELK stack? I will tell you shortly. To build up a data combiner. So let's say you have multiple data sources, each of them is a little bit different, and you want to unify the data from them and send them all into one single instance of Elasticsearch when you can make them searchable. So some business intelligence use case. Again, this is achievable not using only Elasticsearch as a core solution, but also some additional tooling which Elastic Corporation is developing. And of course, in some cases, even though you don't need to index a lot of data, but you can use Elasticsearch just as a mean for visualization. So Elasticsearch comes with an optional module called Kibana, which is similar as a QLake, for example, and or Power BI. and you can use it to visualize data. So put together a dashboard with graphs, with pie charts, with log of records. Everything is simply doable in Kibana, and it doesn't take you much of effort, which is great. Now, short intro into Elasticsearch as such, which will be taken from one of my presentations I did some time ago. So I hope you can see this screen right now. I will make it bigger. I hope it is visible. If not, please.
Yes, it is visible. Thank you for sharing it. It is visible.
Perfect. Thank you very much. So this will be a really short introduction, just so you have a helicopter view and general perspective. What is Elasticsearch and what is it also from the modular perspective? Because Elasticsearch, as I told you, simply put, is a Leucine which was expanded a lot. It is like a solution built around Leucine. And what is standing around, that's the point I'd like to discuss right now. So the ELK is an acronym which is constructed using a combination of the main, let's say, main modules of Elastic, even though the latest approach of Elastic company is they are no longer using this ELK label, because, for example, Logstash is still used less and less, but I think it is still relevant to have a good understanding. So ELK environment is built up using an Elastic, which is the main ingredient, which is the main service, which is able to store data and make them searchable, which is providing also APIs, like interfaces for sending search queries and for receiving results and for configuration of the Elasticsearch. Also, there is a project called or module called Kibana. Yeah, maybe I will just shortly say it now, and then we will go into depth. There is a Kibana is a visualization tool. You will see some screenshots later. So it is about making reports and making data accessible to bigger audience. So if you want to visualize it and show it to your management, or if you want to have a screen which will be installed permanently in your office to monitor your hardware, this is what is Kibana for. Logstash is a transformation module which comes with a great possibility to access also the database. So if you want to convert a data file from a single format to another, or if you want to access a database and extract it from a database and send it to Elastic, Logstash can be used, even though recently they involved something called Ingestion Pipeline, which is part of the Elasticsearch as such, and which can be used instead of Logstash. So you have two options, either use Logstash or you can also use as a part of Elasticsearch Ingestion Pipeline. Then there is a Beats. Beats are some, let's say, data shippers or data crawlers, which are packing data and sending them into Elasticsearch. Maybe the question, what is the difference between Logstash and Beats? Beats are typically small applications which are already developed for some purpose. So there is a Beat, for example, to gather data from Windows log. There is another one which is auditing and monitoring a file. So if there is an update of a file stored on your disk, this Beat application can recognize it and send this updated chunk of data into Elasticsearch automatically. And Logstash is more about transforming from one format to another, to aggregate data, and, for example, to access the database. And finally, the core here is the Elasticsearch. I have there also some introduction about Leucine. Maybe we can skip it or just briefly. This is a detail Apache Leucine and how the data are stored in Apache Leucine. So again, you can see that each document has to have unique ID. Then we are doing some sort of tokenization. So we are breaking the document and the input stream into terms by doing the analysis. And after all, we have an indexed document, which is ready to be used for search. I don't think at this point it is needed to know more, because it is not point of this presentation to go deeper. Elasticsearch here, yeah, this is something I was already touching. There is some continuation. Shay Bannon, who is founder of Elasticsearch, first came with a project known as Compass, and then it was slowly evolving into Elasticsearch. And you probably know that today Elasticsearch is a really big, or relatively big, powerful company which is hiring massively and which is being involved in many projects worldwide. So I think if you take perspective from year 2004, there was a lot of work done. Elasticsearch as a company is also spending some time contributing into the original Apache Leucine project. So it is not only about taking and using Apache Leucine and wrapping it into some nice business solution, but it's also about giving something back to the community. Apache Leucine was originally, it was written in Java, or it is written in Java. It is still being developed. It is not a dead solution or that library, but it was also ported to many other languages. Yeah, that's something I mentioned already. Elasticsearch is a distributed system. We can take it as an abstraction built on top of Apache Leucine. So it is possible to deploy it as a multi-node solution. So let's say if I want to increase a throughput of the system, and I want to be able to digest bigger data sets, I can add more hardware, and for each of new servers, I can deploy, for simplicity, another node of Elasticsearch with the same redundant configuration. And if I have, for example, 3 those nodes, they are creating something as a cluster, I would call cluster. And this cluster then, of course, has much higher throughput capacity when compared just to a single node installation. However, for your experiments, if you are just trying to analyze just few contents, if you are not targeting enterprise use, I think it is nice and okay just to install it on your laptop and just play with small data set. It is completely all right. Completely all right. There is a REST API, which is convenient again, because when compared, for example, to SOAP APIs or the old way API looked, REST APIs are much nicer to work with. I'm not going to describe here more differences about the SOAP XML APIs and REST APIs, but anyone who tried some REST APIs knows that it is more lean and more user comfortable solution. And also it is well described usually when compared to the old approach. And as a format of data interchange, it is JSON. So in older systems, probably you were used to XML for formatted data. Here it is again more leaner and modern. It is JSON. This is about beads, those data shippers or data pumps from our perspective. As you can see, I'm mentioning just few of them, like file bead, winlog bead, packet bead, metric bead. Hardlog bead is, for example, just for the purpose if you want to know whether some computer is up or down. So you will install this very small application to this computer. You will specify the address of the Elasticsearch node, for example, at your second laptop. And this small application is in some interval, which is configurable again, sending just a heartbeat message, hey, I'm alive and I am working. Similarly, There is a metric beat, packet beat. Packet beat, for example, is good for network communication. If you want to get it into Elasticsearch and do some analysis, Elasticsearch was also used for security use cases when you wanted to know, for example, whether some potentially harmful traffic is not present. Or, for example, another nice use case was they were logging the actions users did in some company. So if you were a user of Word, for example, or if you were a user of some text editor and you were using it 4 hours a day, there was a recording of it, like your typical daily schedule, what you did during the day. If you watched YouTube, it was also recognized by application and sent somewhere. And for example, these data could be used again to detect not only productivity, but if you are targeting also not only what users do, but what users access, for example, folders and file share servers, you can also detect some abnormalities and detect if there is some user, some of your employees who is accessing and doing something what he or she shouldn't do. So for analytics, again, it can be great solution. Logstash, what is interesting about Logstash, it was started as a separate project. It can be connected to multiple sources. So actually Logstash can coexist with Beats as well as with other technologies like RabbitMQ, which is message broker, or Kafka, or Redis, which is another type of database. And as we said, its purpose is parsing, processing, and transforming data so it can be sent into Elasticsearch. Nowadays, it is probably worth of considering using ingestion pipelines if you don't need to access databases, because in ingestion pipelines, you have an ability to script the way how the data will be transformed and digested by the Elasticsearch as well. This is Kibana. Kibana is the thing which pops up in user's mind when you mention Elasticsearch. It is a, let's say, front end of Elasticsearch, even though it was started as a separate project as well. And you can see it is very similar to Power BI or any other analytical softwares. And you can use it for multiple purposes. As you can see, there is a master menu with some values: discover, visualize, dashboard, time million, and so on. This is a little bit outdated. Nowadays, Kibana, and I think the current version of Elasticsearch was version 8. And I didn't see the latest version of Kibana, but this is a little bit outdated. Now it is more rich. So there is also a possibility of prefabricating some dashboards and editing them in a sort of template manner. But the main purposes of Kibana can be used to manage Elasticsearch. So if you are going to install Elasticsearch to your machine, you typically don't need Beats, you don't need Logstash, but you typically want to install Kibana. Because if you want something user-friendly, which you can use to configure Elasticsearch, at least when it comes to indices and simple configuration, and if you need something to be able to see data already sent into the Elasticsearch, there is nothing better than Kibana. So you can use it for analysis to check how the documents look like, which are in Elasticsearch. You can use it also to perform queries. So you can perform a search using a nice user interface, or using editor, which is sending those requests to the API, to the interface. That's part of Kibana as well. And as you can see on the screen, there is just some simple field for search query. There is some example search query status 200 and extension PHP. So probably this is a screenshot of some monitoring use case. And in the middle of the page, you can see a list of some documents which are matching some query or which are just listed. And each of these rows is a single document. You can see a highlight of fields. So there is a field index logstash 0, some timestamp, extension JPEG, response 200, some geographical coordinates, and so on. So this is how the documents are visualized, and in the most Spartan way. And of course, you can build up more specialized components like the charts, and also show trends in time and everything you typically need to do with data sets. Yeah, we will see more later. So let's continue one more. Yeah, here I'm mentioning some big players who are using Elasticsearch. Um, what is good about Elasticsearch, even though nowadays it is not completely open source solution, it still allows you to go with some free subscription, which is free to use. You can see in the free subscription or open source subscription, I think nowadays this was changed. You can see this is like, yeah, this is a little bit outdated, but never mind. But still, in the basic subscription, which is completely free, you will have the main server, the Kibana, ability to install and use beats, Logstash, APM. So actually, it is more than you need if you are just playing with data and analyzing some small data sets. In case you are having Elasticsearch as a part of some more robust solution, you typically have also things like alerting, machine learning. So you are able in big data sets to detect some anomaly. For example, the popular case, if I will be gathering indicators about my hardware, I'm able to detect some anomalies in this hardware behavior, and for example, predict that some machine is going to have outage soon. So some more advanced use cases are, of course, available only under paid license. Yeah, there are some additional modules, but I think it is irrelevant, at least for this audience, because I don't think you will need them. And this is about the API. I was mentioning, which is something Leucine didn't have, and which is a big added value to Elasticsearch, because it allows you to do pretty much everything. So if you have some ability to use a REST client application, like you can use Postman, or you can do it with a scripting language you like to use, like Python. You can use this API to send a document into Elasticsearch for indexation. You can use it also, of course, to get this document by unique ID of this document. You are able, of course, to update it, delete it, so all CRUD operations. And of course, you have ability to manipulate with the indices to define index, define how document should be indexed, because for each, let's say, index, there is a template you need to specify. So Elasticsearch knows which fields and how they should be stored in Elasticsearch, whether this field will be a Boolean value or whether it will be textual information. And you are able to do it all over this API. So even though like you are not a programmer, you are more just a technically advanced user, you are able to do it. Here is an example of index API in which I am just sending put request to my Elasticsearch to some index with a unique name, to some document ID, and all I have to do is just to provide the JSON content which is representing my data. You might say, okay, but what about, for example, PDFs? What about scan of documents. Well, for this case, I wouldn't say that Elastic is the most perfect solution. If you want to analyze data from PDF or from images, it is better to have first some OCR, or some let's say segment in your processing pipeline which will extract these data into textual information, and you will be able to send it to Elasticsearch as a JSON content. If you are looking for something which is more prepared for this document-based search, or let's say PDF and scan document-based search, you probably want to experiment more with Apache Solr or other search engines. So you just sent a JSON to the API. Given that index template was already defined, Elasticsearch will index and save stored data in the index or in the document storage. And to perform a search, you must be able to call a different method, of course, and be able to construct a query. The queries are very similar to the Leucine queries, so they are based on Boolean logic. So you can specify that you are looking for some term content, and you can use operators like AND, or you can also use some wildcards. You can use fuzzy search. Fuzzy search means that you can apply evaluation of distance between terms. So it is usable if you are, for example, trying to prevent a situation that you are not able to find some term because of typos a user did. On the other hand, things like fuzzy searching, Levenstein, at a distance, it can be very greedy to computational resources, and this fuzzy query can be a reason why your query is 100 times slower than it needs to be. So in the most ideal case, if you are just looking for a perfect match for few fields, because each document can have multiple fields, and ideally with just a simple combination, it will be very, very fast. Because even the Leucine was able to index, I think, on modern hardware, like 150 gigabytes per an hour. And here the search can be executed in a real time. So you are not waiting a minute or multiple seconds. Typically, you get the results under second. Here is more details about the queries. So case insensitive unless marked with quotes. You can use logical operators, wildcard characters. There is regex query, so you can use regular expressions, even though you must be aware that regular expressions, they are taking a lot of computational time, the same thing as the fuzzy search. Also, it will cost you a lot of system resources like CPU, because you must think about this, that Elasticsearch needs to take the inverted index and compute the combinations on top of it. So if you are creating some search model, it is better to get rid of fuzzy search, regex, and prefix queries and keep it just a really simple ones. There is also some .NET client, which is not very relevant for us. And yeah, there are some additional examples from Kibana. On the right side, you can see a dashboard somebody did. So let's say you are typically wrapping the data for having a big perspective on some domain, which is then presented to a target audience. So in this case, I have all important insights at a single place in the visualization, which is the most optimal one for my use case, and I can use this dashboard for it. In the left bottom corner, you can see an editor, which is simply put nothing more than an API client. So on the left side, in the left side of the editor, I'm able to specify the query I'm going to send to the Elasticsearch. And on the right side, I can see the response from the Elasticsearch. So from Kibana, if I don't have some REST API client application, I can send it like this from the Kibana. And it is good because it is convenient. It supports highlights of the expressions which are specific for Elasticsearch. It is formatting this JSON query nicely, and as well as it gives me some convenient features like, for example, history of those queries. So again, if you are planning to work with Elasticsearch, typically you don't need anything else than Elasticsearch and Kibana. That's it. Yeah, here are some additional examples we can probably skip. I'm just checking whether I did not miss something. I don't think so. And now we will return to my core presentation. So now let's say we want to prepare some data for analytics or for creating a search solution. Typically, we need to be able to cover following key areas. So first of all, we need to be aware of the strategy, how to combine the data from multiple data sources. Because it can happen that you have some content in PDF, some content in plain file, and some content also in images. In that case, as I said, you will need probably something which is able to extract the data from images like OCR, or you need to have also, for example, beads or Logstash, which is able to combine it together. For the structure, there are typically questions like which technology to use. If we are talking about, let's say, rich search solution, which also should store documents, it is questionable whether big documents and documents which should have also some lifespan, like some limited lifespan, should be stored directly in Elasticsearch. So it is again about the use case. Different technologies are matching different use case, and it is not about having everything implemented using only a single search technology. Indexing is, of course, the question how to process the incoming data and how to do it in a reasonable time with reasonable resources, and also how to do it from the perspective how to create a template for the indexing, how to, let's say, uh, take the document and break it into fields which you are interested in, because not all fields or not all parts of your documents might be way too interesting for searching. Some fields will be usable for searching, some fields will be usable for storing because you want to access them for analytical or search result purposes, but some content of the document and some fields can be just omitted, neglected, thrown away, and you can save a lot of time by doing this. So this analysis is needed as well. Also, you will need later to decide about capacities, about the resources you have able for the volumes you are planning to use and process. And of course, query, that's something we mentioned before. It is important to construct query which you can process in good time as well. Because if you have a really small corpus and very small index in Elasticsearch, you typically cannot say a difference whether my search query is good or bad, because on a small sample, you will not see a difference. It will be a difference in microseconds. That's nothing. But once the system go big, and that's the biggest problem, like you have some search solution and everything is ready, and you are just thinking, okay, and now we want just to expand expand the base of data. So we will send there not 2 times, but 15 times more data, and we are expecting the same results, the same criteria, the same performance. And then everybody is surprised it doesn't look like, because they are going to find out that the search query is not perfect. They are using, for example, fuzzy queries, which can be very greedy. Also in the indexing, they are recognizing some problems which were not very visible when a small volumes were processed, and so on. So for naive and small implementations and models, it's completely okay to be unoptimal. It's very good because you can learn new things, but do not trust it will work so nicely even for bigger volumes. Okay, resources is something I mentioned. For the interface, how to make the search available to the users. Of course, this depends. In some cases, you can have an Elasticsearch with Kibana installed in your company and use it as an analyst tool. So all your team is using just Kibana, and if someone needs something else, you are using scripting. In some cases, if Elasticsearch is used as a part of your bigger enterprise solution, you can also implement a completely new interface, which is used by the end users, and which is internally doing nothing else than just calling the Elasticsearch API again. Here I have few just screenshots just to illustrate this. So for integration, this is some example when I have a combination of beats. Beats are harvesting the primary data from the location. Then it is being forwarded. It can be forwarded directly to Elasticsearch, or in this case, it is forwarded to Logstash. And from Logstash, it can be sent finally for indexing to Elasticsearch, where I have like multiple nodes. There is also some distinction between hot and warm nodes. In bigger installations, it is possible to say that, for example, this hardware will be used only to store data, and this hardware will be used to index and also for search service. So it is possible also to say that some data are old enough to become let's say eligible for a removal. In that case, again, I can remove them directly, or I can say let's move them to the poorer devoted hardware, which is used exclusively for some data, which can play the role that some hardware, let's say weaker hardware, can be good enough for all the data which are not accessed so frequently. And even though I have a poor hardware which gives me bigger retrieval time, it is okay because these data are old and they are requested only once a year, for example, when compared to the production hot data, which I need to have on the fastest possible hardware to have the smallest response time for retrieval. Of course, as I mentioned, Logstash nowadays is a little bit crowded out by Ingestion Pipeline. Ingestion Pipeline is part of Elasticsearch, and it allows you to specify that if there is some input in a format of JSON coming to Elasticsearch, you can transform it. You can, for example, replace values. You can remove some fields. You can apply regular expressions to this content, and just then it is sent for indexation to the Elasticsearch indexing service. And when it comes to structure and whether some technology is appropriate or not, here I have just some interesting, or I think it is good for summary to understand that really sometime inverted index, Leucine, and Elasticsearch can be an overkill for your use case. For example, if you have a relation database, and in this relation database you are accessing records using unique IDs only, then you are good. But if you are falling into this category, which is shown here on the first orange orange rectangle in which I'm trying to find from a table all records which contains name containing John and Doe segment. This is not very good for relation database. This is not very good use case for relation database. And again, if you will have in this relation database just few thousand of records, it will be completely okay. But once you go to millions, you will have to wait a lot, and you will have to think about some better solution, which can be, for example, the inverted index, in which this combination and this search is really a piece of cake. This is one of the simplest cases. Another thing to consider, of course, is what about NoSQL databases. Apache Leucine Elasticsearch can be used as a database storage, just a key value store. But in that case, if I don't need to index it and search in it, then I probably like to use some NoSQL database like Mongo, Cassandra, or something else. This is another thing. On the left side, we can see a query which is constructed in Kibana. Okay, this is the standard approach, which is very much similar to the approach which was in Leucine. But on the right side, you can see a new approach, which is available from, I'm not completely sure, I think it's version 7 something. And you are able actually to request data from Elasticsearch also to use SQL language, SQL construct, which will be internally translated into a query. And on the right side, you can see the results Elasticsearch returns. So it is very interesting how Elasticsearch is also making the solution even more convenient. And even if you are an analyst who is not completely comfortable with the Elasticsearch way of querying, you can use this SQL-like format to get results, which I think is perfect. Indexing, how to make data digested and ready for search. Here are just few areas which is good to recommend. So first of all, you need to do some analysis of the documents and be prepared also for the edge cases, and be prepared also to remove noise from your data collection. So from the perspective of Elasticsearch, you need to choose appropriate data type for each field you'd like to have indexed. Of course, you need to decide whether this field, for example, should be indexed at all or not. If you not make it, if it's not indexed, of course, you cannot use it for search. Another thing is, if you are indexing big volumes of data, like many documents, you shouldn't send it one by one. It was same principle even in Leucine, when indexing and updating index one by one was causing performance costs. But if you send it in a big bulk of documents, it will be much faster. Some decision whether to index, whether to store the data, that's important as well. And final, you need to decide for some enterprise scale solution, what is the projection for hardware. Not only because of the performance, but also, as I mentioned, for the high availability, for the emergency cases. If you are, for example, insurance company, and this is a part of your business critical infrastructure, you just cannot afford that failure of one data center will kill your operations for 2 days. That's not way to go. One more thing here, when it comes to the way how you are indexing data. This is something you probably know from Google. Google is from time to time suggesting whether you didn't make a typo. And on the right side, you can see an example of results received from phonetic function, from phonetic hashing, which is in this case metaphone. In Elasticsearch, and this can be very good. For example, if you wanted to implement this Google recommendation engine, or if you wanted in your search somehow project and evaluate also a similarity when it comes to phonetic aspects. You can use filters or phonetic plugins. So there is a support for Soundex as well for Metaphone. And what those hashing methods are doing is they are taking terms and they are trying to hash it into a unique hash, which is very well expressing its pronunciation qualities. So if you take a look on the table on right, and if you take a look on a record number 2 and number 3, you can see the hash, at least when Metaphone is used, is the same, because the pronunciation of these two surnames is the same. But if you look on number 4, 5, even though they are very similar, they are having different hashes. And Metaphone and its newer version, Double Metaphone, they exist for multiple languages. So it's not like there is just a single way of pronunciation, because of course we are not all English speakers. So you can find many flavors, many variants you can use. And it can be also very helpful, because if somebody, and it happens very frequently, is making typos, you can decide whether to use some fuzzy query to have some grace, let's say grace limit. So even if there is a difference in 2 characters or 3 characters, it's still acceptable. But additional or another approach could be also, as a part of indexing, to create this phonetic hash of the content. And then when you are searching, you will take the search criteria, the search term, you will create another phonetic hash, and then you are comparing the hashes together. So this can be very helpful to find the right content. And this takes me to the query. In the queries, some recommendations: you should use queries as simple as possible. You shouldn't try to do complex queries with multiple fields, with multiple aggregations, boosts, regex queries. That's not the way to go. If you cannot do it this way, there can be also a problem in a structure you are using for indexation, because one of the biggest inconveniences with Elasticsearch is, once you have an index and you want to change its structure, you need to re-index, or let's say migrate the data from the old index to the new index in a new structure. So it is always better to experiment with the index structure first, and once you have a sound index structure, use it also for production data. Because otherwise, if you want to do some massive changes in indexation, it can be costly. If you want to do some massive changes in query, fortunately, to change query is always simple, but it is not always simple to have query which is highly performant. Avoid Levenstein. I can show it here. You probably know it. It's not something complicated. It is an edit distance, which is showing me what's the difference between these two blue labels. There is one difference in one character, which means 9% difference. There are different alternations of this algorithm. There are different approaches how to consider the edit distance, but what is important from the perspective from search engine, even if the temptation is very high to use it, if you don't have to use it, do not use it, because it costs you a lot of time, I mean computing time, because you need to evaluate all the combination from the inverted index. And also, there is some security limit that is, I think, hard-coded into Elasticsearch, that you are not able to use Levenstein, like acceptable Levenstein distance in your queries, which is bigger than 2 or 3, I believe. Which is there because in case you would be accepting Levenstein higher than 4, for example, you would be matching too many terms and it would be too demanding to compute it. Good thing is, if you need still to use Levenstein, it is very helpful to put there a configuration that at least the first character must be the same, like a prefix length. If you say prefix length must be the same and you are securing yourself only against the typos in the latest or later character in this label, this will improve the computational demands notably significantly. So that's one way what you can do. And also in the newer versions of Apache Leucine, there is new approach, which is based on Leucine automaton, which is based on, let's say, preparing a structure for your search criteria. So the string or the term you are searching for is taken, and out of it an automaton is generated, and you can save a lot of time if you are doing multiple many combinations and many comparisons with the data from the inverted index. So in newer version, using new version of Apache Leucine, the Leucine can be because of this faster, like, I don't know, 100 times, for example. But of course, if you need to perform Leucine without any such preparation of automaton, it is always very greedy. Use ingestion pipeline. Yeah, as I said, this is very nice thing to use. It can help you, those of you who can use Java. Actually, Elasticsearch internally uses some dialect of Java, which is called painless. It is similar to Java, so you typically do not have any problem. And you can use ingestion pipeline to specify which procedures should be done before the data is indexed. So you can, for example, anonymize some fields, you can normalize data. Hypothetically, you would be also able to call some external library if you are more like programmer-like. You are able to perform regular expressions, validations, and so on. So very nice thing, nicely configurable over Kibana as well, because all these scripts you are setting up over API from Kibana, for example, as well. And okay, finally, appropriate number of hardware and nodes. Again, this can be like hardware aspects can be important. This is the last area from key areas to cover. So from interface perspective, if we are going to use this in-house, we typically are going to use Kibana or our REST client of our choice. Another approach is to develop some interface which is just calling Elasticsearch. And another approach is, which is available since Leucine, if you want to inspect Leucine dataset, there are tools like, for example, this one, Luke, which helps you to access Leucine indexes and see the data, how they are stored, and you can also access the documents data. So that's more like for debugging purposes. Here are a few good links for those who are interested in those technologies. So I think if you are mostly focused on analytical side, I think Kibana is your point of entry. And in that case, there is a nice demonstration page. I hope I will be able to open it. It's called Elastic Demo Gallery, and it can show us nice prefabricated dashboards. With some use cases like here, for example, flight data. Here we have some business case. Here we have business traffic, revenue dashboard. So we can show, for example, the dashboard for flight data. You can see it's modular. You can see if you want to, you can specify filters, like from which time range I want to show data. And there should be ability to select like the flying control. It looks like probably they are maybe outdated. We can try a different demo. Yeah, we can try, for example, this canvas. Yeah, this is in Elasticsearch. You can see this is very nice for reporting. So you have the data in Elasticsearch. You have some views defined, and after all, you can create this dashboard, this report page, which is very it is eye candy, and also it is very transparent. So I'm definitely recommending to take a look here. In case you would be starting with Elasticsearch, I'm also recommending to use this page because there is a lot of data, a lot of tutorials. It is very straightforward. Sorry, Elastic users. So if I go to, for example, products, Elasticsearch, you can see there is the elk stack. I can see their documentation. I can see there more details about all of these modules, and it is really, I would say, convenient and fast to learn. One thing I didn't mention, you are completely perfect if you have a laptop with Microsoft Windows. You are able to run Elasticsearch of Windows. There is no problem at all. Or if you have a Unix-based operation system, it is possible as well, of course. Okay, here I have more details about Leucine tutorial, which is nice page about Leucine, showing how the queries are constructed. This can be helpful also to understand how Elasticsearch works. There is some comparison with Leucine versus Solr. As you know, Solr is also based on Apache Leucine, and it can be taken as a concurrent to Elasticsearch. And in case you are interested in Solr, I think in that case it is better to navigate to their homepage, which is this one. Yeah, again, there are resources, information about performance aspects. There is a good community, so you can chat with them in discussion boards. So I think the technology is definitely there. I tried to provoke your appetite for this technology because it is my favorite one. I hope you enjoyed it. And now there is a time for your questions.
Yes, thank you, Marek. I really appreciate you giving us such a vivid information. I mean, this is absolutely new for each one of us. So I can see, the stories of the visualizations and how, Elasticsearch can definitely, it's not just the text mining that I'm looking forward or the textual analysis. It has got more of it if we dig deep into it. Now, before I can raise certain questions, first of all, I would like to take up the questions which has been put forth by our participants, first of all. First question is, if Elasticsearch is free, then why subscription is there?
Okay, I think the subscription can have the reason. First of all, if you have a subscription, you're able to monitor who is using and how many people are using your product. Because in some cases, if you are asking a free subscription, uh, it is good to get your contact data. So later on, you can receive some offer. For example, you are probably using our product. What about upgrading to a better subscription? So I think it's a part of a marketing model. It is true that Elasticsearch is not purely open source. They are contributing back to the Leucine, to the Apache Leucine, which is open source, but the Elasticsearch is using the subscription model, which is not something completely extravagant. I know many other before open source solutions which today migrated to subscription model as well.
Okay. Now, second question is whether Elasticsearch can generate trading signals like buy or sell based on some events also in financial domains.
That's a very nice idea. Actually, I was developing something similar as a just some prototype. Actually, it was not using Elasticsearch, but simply put, if we take this as a use case, what you need to have a connector which is able to take the latest data. And now the latest data. I mean, you can take, of course, information about prices. That's one thing. Another thing is you can take, for example, data from news. So you would need to do some sort of sentiment analysis. For example, whether the sentiment around Bitcoin is getting higher or lower. So that's all I think it's possible to get data for this by something like Beats. You can send it into Elasticsearch. And in Elasticsearch, you can use, even though it is probably paid module, the machine learning module, which would be able to implement a model for detecting some patterns. And Elasticsearch already have also alerting module, so you would be able to automatically send a notification, and this notification is easily translatable into some automatic buying or selling action. So yeah, like for some simple like example for some simple implementation, yes. I think the biggest question is whether it would be profitable for you, and that's of course something more hard to answer.
Okay. All right. Now I have the next question. Does Elasticsearch has support for multi languages for handling request and response data?
Mhm. Uh, okay, I think it is like this. If this is meant like we are going to process data from some specific region when English is not used, this is okay. I think it is only about ability to choose the right tokenizer and analyzers. So you must be capable of choosing, and also because Elasticsearch, and it is the same as a Leucine, is coming with some preset of analyzers. So for example, there is an analyzer which is relevant for English-speaking countries, and if you use this analyzer, it does for you, it is tokenizing the sentence, it is removing articles, it has some filtering stop list of words, and so on. And this is like a bundle which already exists, and it is coming with Leucine or Elasticsearch. In case you want to have something custom, for custom language, for example, you definitely can create such bundle quite easily using those small particles like a tokenizer and filter and so on. And then you have this data in Elasticsearch, and you have to decide, for example, what else you are missing. For example, the phonetic algorithms can be very helpful. And as I said, the metaphone is available in multiple mutations, which are prepared not only for English, but you can find also double metaphone, I think, for French. I saw some other European languages. And if you are not satisfied with it, you would be able also to take this open source code, modify it, and create your own plugin. So definitely, if you have this interest and you are motivated enough, the simple things to customize it are very straightforward. More demanding things like creating your custom phonetic analyzer, it can be more demanding, and it is questionable whether the trade-off is worth it.
Right, Merrick. Now, next question is how much data can Elasticsearch hold? Because this is the era of big data. So, when we are talking about big data, and since, the entire model which I'm seeing is based upon machine learning, so do you think that we can go ahead and say that, yes, it can handle big data, or is there some kind of a limitation to that?
Yeah. First of all, I'm not 100% sure what is the maximal amount, for example, when it comes to machine learning. I didn't work with machine learning here, but when it comes generally to the Elasticsearch, it is scalable solution. So you are really able to add more servers. You are able to have more data centers which are synchronized. So it should be usable also for really big data.
Okay.
So I'm not sure about the machine learning clearly, but for big data, because Elasticsearch is used, for example, by big companies like Netflix, and their volumes are not small. So I don't think it's a big problem.
Okay. And what is elastic mapping? Like, I think in one of the scenarios you were talking about that. Can you please explain to us more on it? What is elastic mapping?
Yeah, elastic mapping is something I called for simplicity a template. So each time you are defining index, you need to define what is the expected document structure, like which fields this document contains, whether this field will be a textual field, a numeral field, and so on.
Okay.
And also as a part of the mapping, you need to specify, or you can specify some additional parts which will be used as a part of indexing or search. So mapping is like the template which is used for definition of your search model. And typically it's not easy to change them on the run. You need some migration.
Okay. Now, next question is, Marek, do we have options such as word cloud, stop words, limitization, stemming in Elasticsearch?
Definitely, definitely. And the good thing is, many of those are available directly from Elasticsearch. So if you go to the elastic.co, I think you can find there plugins already existing. Uh, but very good thing is, if you know GitHub
Mhm.
site. You can go to GitHub, and on GitHub you can find many additional plugins for Elasticsearch. So that means if there is somebody who already developed something, you can download this plugin, copy it into file system with your Elasticsearch, restart Elasticsearch, uh, be hoping Elasticsearch will recognize this new plugin, and then you need just to call it from your ingestion pipeline, from your search query, or from your indexing pipeline. So definitely lemmatization, stop words, yeah, that's all available. There are also some nice plugins, for example, Carrot, which can be used for clustering of data, which can be useful for sentiment analysis. And again, you will use this plugin. You will have Elastic as a search solution and analytical solution, and you will have Kibana in which you can show this clustering for the sentiment analysis. So yeah, it's very easy to do.
Okay. The next question is, Marek, thanks a lot for answering that question. Is indexing done as it is being taken care using, in Python when we go ahead with the concept of dictionary? So, do you think that indexing is that only similar to dictionary in Python?
Mm,
Or you would
it,
say that because in Python and R, I know we have index is different and dictionary list, all those things are different. So, do you think that it is same as dictionary, or do you think it is different?
I would say it like this: the core concept
Mhm.
is the inverted index, which is about having terms and their pointers to the documents to which they belong to. You can use this abstraction and implement it using a simple dictionary. That's possible. If you want to implement an inverted index in Python, you can do it using a standard keyword value dictionary in which term is a keyword and value are those references to documents. That's of course possible.
Okay. Thank you, Marek. Now, questions from my end now. So that is the end from the side of the participant. Now, as I was going through your entire presentation, I was also observing that there is a lot of technical jargon which is involved in this entire scenario. So, do you think that the person who is going ahead to use this particular tool needs to have a very strong background in technology also?
That's an interesting question. If I was and if I was a advocate for Elasticsearch, and I am because I like this technology, I would say Elasticsearch is probably the best technology to use if you want to start learning and trying to play with this type of use cases like search engine and analysis of data, at least with this approach. Uh, because there is nothing with so shallow learning curve. What you really need to be able to use, I think you need to understand what is API. You need to understand something about databases and document databases. What is the difference? And then you need to have some analytical mind, like be able, if you are given with JSON, with some query, be able to read it and be able to understand logical constraints. So I don't think like it is very complicated to start because there are also many introduction series on YouTube. You can find tutorials, you can find nice articles about doing simple things for starters. So I think if you have interest in this area, if you see an opportunity to use this technology, I think this is the best way to go. And I think it will be doable also for persons who are not so interested and not so tech savvy and are only interested about, let's say, analysis and models.
Okay. Now, one more question that I wanted to ask you is, since you are using the words like index, then pipelines, I have seen databases that you are using. Now, coming from the background of little bit of R and Python, I find that somehow that yes, if I'm able to learn R, I'm able to learn Python, then working with Elasticsearch should not be a very difficult one, right? Only hitch would be in developing those queries, correct? The codes, I mean to say.
Yes, yes. If you already know Python, what you need as a next step, you need to be able to have instance of Elasticsearch,
Okay.
which is very simple to install. Simply
Mhm,
put, you just download a file which has its own installer, or you download a zip archive. You
mhm,
will unzip it somewhere, you will run it.
mhm,
You will get some local URL,
mhm,
and then you will download from the internet an example how to call this Elasticsearch URL. For
okay,
example, just to see your Elasticsearch instance is
mhm,
working. Then you need like three things. First thing, you must be able to specify the template, the mapping for Elasticsearch,
mhm,
which I would recommend to start really with something simple, like for example, a person document which contains name, date of birth, and telephone number for just for playing. So you will set up this in JSON. You will send it using Python to your Elasticsearch. Elasticsearch will acknowledge it as like, hey, okay, I'm aware you want to create a new index. It will use this mapping, all right.
mhm,
Then you will send some data to this index. So you will be sending some testing dummy data with fake subjects. You will get acknowledged back from the Elasticsearch saying like, okay, I am aware you received, I received subjects. And then the best thing would be either, again, use Python to search for some of these fake subjects, or better, to run Kibana and inspect the data you uploaded from Kibana. But there is one thing I didn't tell you. If you install Elasticsearch and Kibana, I think it is possible to install it also with some testing data set. So even if you don't have this Python with the subjects and with this mapping, I believe you can set up some testing index and you can browse it, you can play with it with Kibana. So maybe that would be the best like first step to learn something how to do in Elasticsearch and then upgrade it when Python is used as a part of your solution.
okay. Now, one more question, Marek. Now, here, I have seen that the query that you're developing, the relational databases, So mostly my relational databases I would talk about, or in fact, I have to ask you this question. Now, the data that we are talking about right now is exclusively in the text format. Am I right?
Sorry. Could you rephrase it?
Okay,
In
what
your
I'm
relation
asking you
database?
is the data that is to be like in other like I am specifically looking from the side of the qualitative data. We have got images, movies, films, documentaries, and the text. The PDFs and the Word formats for the books or journals and all these things. Now, in that way, where is Elasticsearch stands? It's basically on the data that we are just going to feed in into the system and then carry back.
Yeah, let's put it into some use case. For example, you mentioned movies, right?
Yes, that's right.
So I remember one project in which we took subtitles for
Mm-hmm,
movies.
mm-hmm,
So we took movies like blockbuster movies like Star Wars. We took like cinema art movies and local movies,
mm-hmm.
and we sent into Elasticsearch like documents,
Okay,
which were, and it was tokenized not only as a single words, but we used also chunking, so we get information about which character was saying what, because it was also important.
got it.
So
Now I'm able to understand that. Yes, I have to get it into the format of the text, and then you're going to insert or import it into the system, and then we are going to go ahead with the analysis. Now, when we are talking about the analysis, is it more on the numeric style? Because I could see there were graphs, charts, donuts, pie graphs, and everything. So ultimately, you are focusing more towards the numeric results. Am I right on that also? Yes.
yes, what was shown was about these numeric aspects. Yeah, that's correct.
It's correct. Now, those things are again, we have to go ahead and, I mean, put them into the codes, or we just have to use certain, again, just like Kibana, you said, like, I haven't yet seen thoroughly how Kibana is working. Or is it, why I'm asking you these questions is that lot of us are quite naive when it comes to the query building, using the programming languages on one side. However, when I see the analytical part of it, I feel very comfortable, because most of us who come from the research background are well versed to look into the numeric data and then understand the, let's say, bar graph or a histogram or a pie chart or a correlational, let's say, a chart that you are going to give it to us. So my this thing is that, are you talking more about a mixed methodology kind of a qualitative research that I'm going to do? Or is it that, yes, you have given me the data set, and from here I'm giving you the numeric part of it, and it's like merging both of them together?
Well, it depends. I think Elasticsearch, you
Mhm.
can really use it to support your methodology,
Okay.
because you have the flexibility to not to code something, but
Mhm.
if it is about recognizing some pattern, you can cover it by using the query in Elasticsearch, which
Okay.
can then be quantified and shown in Kibana. But if you, for example, don't want to use Kibana, you are perfectly fine just to taking data from Elasticsearch using Search API into Python, and in Python you can do additional processing as you would usually do. That's possible
Mhm.
as well.
Okay, got it. Fine. So that is what, and I think I have understood, Elasticsearch in that way. And thanks to you for suggesting me, Ramini, rather than looking at the other side, I would like to introduce Elasticsearch. Now I'm able to understand what is the importance of it via the mail communication and why you wanted to suggest this one. Now I just have to see, how well we are able to be comfortable with the entire tool and go ahead and use it for ourselves also side by side, Marek. And I think most of us will definitely, approach you to make us understand more and more, because, it's not just Elasticsearch that I could see. You were talking about Leucine, you were talking about Apache, and there were a lot of them which were present. So, when I was looking at it, I thought, okay, now that means the time has come wherein we are, going ahead and even understanding these kind of things also for our query building, or maybe for the further research in that matter. So I think I would love to thank you out here, not just think, but in reality, because this is something which is taking us in a new direction for ourselves, wherein I know my data, that it can be a qualitative data that I'm taking care of it, and irrespective of the other softwares which are there, which are telling us, okay, you go ahead, do content analysis, thematic analysis, and everywhere. And we don't have that numeric data attached to it, as I can see out here. Now here, a lot of numeric data you're attaching to my qualitative data, whatever it has been, and through, again, a human intervention, wherein the entire process I was able to see. Now, in that way, it's a very good tool for me, Elasticsearch. Now I will have to put in my efforts to see how well both the qualitative as well as the quantitative, because I haven't seen any other tool giving me such a strong results, for myself. So in that way, I think it had been a very good session for me. And I really thank you, Marek, giving us such a wonderful presentation, going step by step to showcase to it that, yes, you see, this is one tool, again, wherein you have a lot of effort has been made to make you understand, wherein many people, when they say that qualitative data, we do not trust it. Now, this is where I can come in and I can show that, see, now I'm giving you the numeric results for it. So hats off to you for giving us such a wonderful presentation, Marek. Yes, now I think there are two people who have raised their hands. One is one of our participants. So Apurva, maybe you can go ahead, you can unmute yourself and you can ask Marek your question. Apurva, are you there? I think
Yes,
so.
ma'am.
She has
Yes,
lost.
ma'am, I'm there.
Yes. So please, you have raised your hand, so you can.
Ma'am, it was by mistake.
Okay, by mistake. And there was
Yes, ma'am.
somebody else also who raised the hand in between. Buddhadev, I think he was the one. So are you there right now? I don't see them present. So Marek, I think in that way we can come to the close of the particular session. I thank
Okay.
you for giving
Okay.
me some of your valuable time, and I know what time it is right now over there. So thanks a lot for waking up for such a long time and giving us some of your valuable time. So,
Thank you very much. It was a pleasure. We will stay in touch. Thank you very
and
much. Have
of
a
course,
great
yes, I
evening.
would be in contact with you, and I have to, come back to you with certain things, and I'll be speaking to you again over the mail. Okay,
Sure.
thank you.
Sure.
Thanks a lot, Marek. Take care and good night now.
Take care. Good
Yeah,
night.
thank you.
Bye-bye.
Thanks a lot. Okay, thank you, participants. I think 14 of us. I see that going slowly, as how many of you are really showing your interest. Now, this is the strength of our workshop, and each one of you, Kalantar, Apurva, Yasha, and I'm talking about Nancy Gupta, Rajendra Lamsal sir, Kanan sir, Felix, and Lal definitely is Buddhadev. All of you, are trying to showcase, and you are able to see now another way in which we are looking at the qualitative data on one side, and on the other side, how the quantitativeness is also coming. Reason being, which I haven't yet discussed with you, that qualitative and quantitative, the bridge has already been taken care of due to these technologies which are there. And now we have reached to that part. I was thinking that I would go ahead and discuss more about it in my class when the session which will be there, and maybe I will be discussing more about it. So I think tomorrow I'm not going to take a lot of time. 9:45, Shong is going to join us up. He is joining from Silicon Valley. So it is the Pacific time for him. That means it would be quite late again for him and quite early for us. So if 9:30, I'm going to join up, and tomorrow 10 o'clock is the time when he would be there. And he's a wonderful person. JPM Pro is, again, you should see all by yourself. I'm not going to talk much about it. And he's going to give you hands-on experience for IBM SPSS modeler. So, all of you kindly be on time. It's a wonderful session that he would be taking up, and he's a very nice person also. Till then, thank you. Let me see you all again at 9:45 or 10 o'clock in the morning. Till then, thank you and good night. Take care. Bye.
Thank you, ma'am. Good night.
Good night.